So here are some additional examples for factoring trinomials. We're going to run through the 5 that you can see on the screen here. And I'm just going to kind of run through these quickly and talk my way through them. Keep in mind that factoring trinomials is a skill that it takes a lot of practice to get good at. So you are not going to get good at doing this by simply watching me work through these. However, if you feel that you might need to see a few more in order to kind of get you started on this, this is a great place to start. So we're going to start with the first example here. We've got a trinomial. We're going to do our best to factor this into a couple of binomials here. So I'm going to start by looking at my first term here, which is k squared. I'm going to write down all the different things that I can multiply together to get k squared. And I can pretty much guarantee it's going to be k and k. Now this 32 over here, I got some options. We can get 32 from multiplying 1 times 32, multiplying 2 times 16. 3 is not going to work. Let's see, 4 times 8 will get us 32. 5, no, 6, no, and then, yeah. So those are our 3 options here. So we're going to begin the process of guess and check now. We know that our first 2 terms have to multiply to give us the first term, so that's going to have to be a k and a k. Only one option there. And then we need to start working our way through these other options. Now, 1 and 32, I know I'm going to have to multiply those, and we're going to have to come up with a 4k. I just don't think that's going to happen. I'm going to cross it off. I can always come back to it later. We could try 2 and 16, just to illustrate how we check. We do 2 times k to get 2k. We do 16 times k to get 16k. Is there any way I can combine a 2k and a 16k, either positive or negative, to get this 4k here that I'm looking for? The answer is no, so 2 and 16 is not going to work either. We could switch to 2 and the 16, but since it's already k and k, it would be the exact same thing. It's not really going to change anything, so let's eliminate that as well. I think it's going to be 4 and 8, but let's just do a quick check and make sure that works. 4 times k is 4k. 8 times k is 8k. Is there any way we can combine these to get this positive 4k that we're looking for? We sure can. We're going to need the 8 to be positive and the 4 to be negative. 8 minus 4 gives us the positive 4k. So I'm going to have to go ahead and put a minus there and a plus there. Just a quick last check. K times k is k squared. Negative 4 times positive 8 will give us the negative 32 that we're looking for. Final answer here is going to be k minus 4, k plus 8. Okay, next example. We've got 5a squared. So let's start by writing down how we could get that. I could multiply 1a times 5a, and that's pretty much it. So yeah, we've only got really one option there. 36, we can get a 36 by multiplying 1 and 36. 2 and 18, 3 and 12, 4 and 9, 6 and 6. So we've got a lot of options going on here, so this could take us a little bit longer. Let's go ahead and start trying them out here. Now, the one nice thing is that I know that's got to be 1a and 5a. Actually, let's just call that a. We'll start working through our options here. Now, a lot of times I'm going to start with sort of the numbers that are closest together. So I'm just looking at that 4 and 9, and I feel like it might be worth giving it a shot. So I'm just guessing here. Let's see, we got 4 and 9. Let's try this out and see if we're going to get the negative 24a that we want. 4 times 5a would give us 20a. 9 times 1a would give us 9a. And 20a and 9a are not going to combine in any way to give us negative 24a, so that's out. Now, in this case, it's worth checking to see if we switch the places. This would give us a different solution, so let's try this out. 9 times 5a would be 45a. 4 times a is 4a. Any way we can combine those to get the negative 24? No, that's not going to work either. So it looks like my gut instinct about the 4 and the 9 was incorrect. Let's try that 6 with the 6. We only need to try this once because if we were going to flip the order of the 6's, we'd still have the exact same thing. Let's check it and see if we're going to get this 24a that we need. 6 times 5a is 30a. 6 times a is going to give us 6a. And yeah, I think we can make this work. We need to get a negative 24a. So if we took the 6a and made sure that that was positive, and then subtracted the 30a. That should give us the negative 24a we want. Okay, so we want the 30 to be negative. That means we're going to need a negative 6 here. We want the 6a to be positive, and now we need to be positive there. We'll just do a quick check with the other terms and make sure that they work out. This is a times 5a, which will give us 5a squared. We got negative 6 times a positive 6, which will give us the negative 36 that we're looking for. So, yep, looks like we got there. Not too many tries. A minus 6 and 5a plus 6 is going to be our final answer. All right, got another trinomial here. And, ooh, the thing I noticed about this one right off the bat is the 9m squared and the 16. Those are both perfect squares. We could get that from 3m times 3m. This could be from 4 times 4. I'm going to try, before I do anything else, I'm going to go ahead and try those values in my factors, because oftentimes these are going to work out, especially when you see perfect squares at the beginning and end. So I'm going to try 3m to get the 9m squared. I'm going to try the 4 and the 4 to get the 16. Let's just see if that'll work out to give us the negative 24 that we want. 4 times 3m is going to give us 12. 4 times 3m is 12. Oops, make that 12m for both of those. And can we combine those to get the negative 24? Yes, yes we can. We're going to need both of those to be negative. Negative 12 and negative 12 will give us the negative 24. So that means these signs are both going to be negative as well. So in this case, by utilizing that kind of trick that I showed in the notes, if you always look to see, if you happen to have perfect squares at the beginning and the end, just go ahead and try that out. It's not guaranteed to work. If this hadn't, I would have gone back and I would have gone ahead and made my list. 1 and 16, 2 and 8, 4 and 4, and I would have just started guessing through that list to see if we get it to work out. But in this case, it did work out. Okay, a couple more here. All right, let's see if we can get this guy to factor. Let's start with the 6x squared. Now, we got more than one way to get this. This could be 1x times a 6x. It could be a 2x times a 3x. Those are only two ways to get that. So, multiple options there. We've got multiple options for the 10 as well. It's either 1 times 10 or 2 times 5. So this one could potentially take us a little bit longer. We'll just kind of see how it goes. I usually shoot for the numbers that are closest together, so I'd probably try the 2x and the 3x to begin with. But this is just a shot in the dark. We'll see how it works out. It could go really quick, or it could take a really long time. Let's go ahead and try the 2 and the 5 here. So I'll put the 2 here and the 5 here. Now, so again, this is one of those advanced tips. Since our original trinomial didn't have a common factor, then this can't either. So there's no way that that 2 and the 5 can go in like that. We go ahead and try flipping them, put the 5 here and the 2 here. That is a possibility. We'll go ahead and check it and see if we get the positive 59 we need. We got 15x, 4x, and yeah, there's no way that's going to get us to a positive 59. So the 2 and the 5 is not going to work. Let's try the 10 and the 1. I don't know, 1 here, and well, actually I'm thinking 10 cannot go there, so the 1 would have to go there. 10 can't go there because that would cause us to have a common factor of 2 in there, and that just can't work. So we'll try the 1 here and the 10 here. Go ahead and work it out. 1 times 3x is 3x. 10 times 2x would be 20x. And no, that's not going to get us to 59 either. So I believe we've eliminated 2x and 3x as a possibility. We've tried them with every combination possible from the factors of 10. So 2x and 3x are out. Let's try 1x and 6x. So I'm just going to call that x instead of 1x. 1x and 6x. And I don't know, let's go with the 1 and the 10. 1 and 10. Now I'm not going to bother checking this one because 6x and 10 both are divisible by 2, so that's not a possibility. I could try flipping them and putting them here. Yeah, let's try that out. 10 times 6x would be 60x, 1 times x would be 1x, and oh, that'll work, that'll work. We're trying to get a positive 59. If we made the 60x positive, the 1x negative, that'd be a minus, and this would be a plus here. So quick check to make sure that all works out. 1x, or x times 6x will give us 6x squared. 10 times negative 1 is giving us the negative 10 that we want, and that middle term we're going to end up with as well. So final answer on this one, x plus 10, 6x minus 1. All right, this will be our last example for this topic. Again, we've got a trinomial. We're going to try and factor it into a binomial. Let's start with looking at our options to get this 8p squared. So that's either 1p times 8p or 2p times 4p. This 15 could come from a 1 times 15 or a 3 times 5. So we've got a few options here that we may need to try. Let's give it a shot and see if we can work it out. I'm going to try the 2p and the 4p to begin with. And I don't know, the 3 and the 5. Let's try the 3 and the 5. So I'm going to put the 3 here, the 5 here. See what we end up with. So we need to check. I'm looking to get a 14p here. So I've got a 12p and a 10p. And yeah, there's no way I can combine those to get 14p. So this is incorrect. I'm going to go ahead and switch these two. Try the 5 here and the 3 over here. And see if that works, and if not, then 3 and 5 definitely don't work with this combination. 5 times 4 is 20, 3 times 2 is going to give us 6p, and yeah, that'll work. We want positive 14p, so we want a positive 20 minus 6 would get us that 14. So if the 20 is going to be positive, we need to make that a plus 5, 6 is going to be negative, that needs to be a minus 3. So our final answer in this one, 2p plus 5 and 4p minus 3.